one last result here that's still somewhat abstract. Suppose, and let's come up with a name, W is a subspace of a finite dimensional vector space V. Now there's a symbol we haven't seen in a while, so it's time to try to get a basis proof that involves direct sums. So we have W, which is a subspace of a finite dimensional vector space V. Then there is a subspace, I'll use UVWWX. There's a subspace X of V, so V is equal to the direct sum of W and X. Okay? So this looks, I guess, similar to some results because we've been extending things, but now we're trying to do this sort of, it's a simple statement with subspaces. I have a subspace W of V. I can always find some other subspace so that V is equal to W plus X. Now, if W is all of V, then it would just be the zero subspace, and this would be trivial. So suppose not. Well, let's proof. So suppose W is not all of V, and W is not the zero subspace. Okay, because otherwise I could let X be all of V, and that would work. Well, now what? Well, in this case, W is finite dimensional, right? We proved that. So we proved W must be finite dimensional. Okay. So now that I know that W is finite dimensional, what does it mean to be finite dimensional? So W is equal to the span of some W1 through Wm for some vectors. W1 through Wm. Now I also know that we could extend these vectors to form a basis from our other result. So we're using our previous results here. So we'll have W1 through Wm, and then some new vectors, which I'm going to call X1, gasp, you saw that coming probably, through Xn. So I know this is a basis. Now what don't I know? I don't know this. This is what I have to show. I want to show that V is the direct sum of W plus X. So it's been a few proofs since we talked about direct sums, but what does it mean? Well, it means that the intersection is just 0. So we want to show W intersect X is 0 and W plus X is V. So that's what we want to show. Well, I know that, let's see. Oh, I haven't said what X is. So if we set X to be the span of X1 through Xn. Okay. So if we set X to be the span of the vectors X1 through Xn, then I want to show these two things are true. This and this. So first of all, of course W plus X is equal to V. Why of course? Okay, maybe not of course, but I have to show that any vector in V can be written in this form. Any V in V we can write V uniquely in our basis. As V is equal to A1W1 plus A2W2 plus AMWM plus B1X1 plus BNXN. That's because we know it's a basis. We formed a basis. But guess what? This is in W, and this is in X. So we've shown that every vector in V is in the set W plus X. But is every vector in W plus X in V? Absolutely, because all the vectors in W are in V and all the vectors in X are in V, so we have that V is a subset of W plus X and W plus X is a subset of V. So we know that this is equality. Okay, so we could check this off our list, but this is what we have to show now. So we want to show W intersect X is just a zero vector. Okay? Well, if not, then we can write you know what? Instead of doing this by contradiction, let's make this more direct. Let's say if V is in both W and X, then what? Well, if V is in both W and X, what do we know? We know that V is equal to some, maybe not for the same A's here, but V is equal to, I'll use C's, C1W1 plus CMWM, and it's equal to D1V1 plus through DNVN. And then what can I do? Well, I can move stuff over to one side. And what do I get? I get that 0 is equal to negative C1W1 plus plus minus CMWM plus D1V1 plus DNVN. Okay? But what do I know? Well, I know that these are independent because the basis is independent. So that means I know, since I know 0 can only be written in one way, that each of these must be 0. So CI equals 0 and DJ equals 0 for all I and J. So what did we show? Well, we showed that any vector that's in both must be 0, and that's exactly what we wanted to show. So we are done with that proof as well. So basically we can extend subspaces by always finding another subspace to create a direct sum, which is the whole vector space that we started with, so long as we are finite dimensional. So we're sticking to that finite dimensional vector spaces for many of these proofs. So that's something to keep in mind that you need as well in order to invoke any of these.